All right, so today we are going to talk about molarity, which is a measurement of concentration. Concentration is sort of a measure of how much solute is in our solvent. So it's typically a ratio of some sort of solute to solvent. Okay? Now there are actually several different types of concentration you can have. There's molarity, there's molality, there's normality, there's percent by mass, there's tons of them. The only one we're going to actually worry about in our class is molarity, which is moles of solute for liters of solution. So, for example, most of the solutions that I make, I use molarity as my concentration value. Okay? That allows me to figure it out fairly easily. This is probably the easiest of the concentration calculations. So, volume conversion factors you need to know. 1 centimeter cubed is 1 milliliter. 1 decimeter cubed is 1 liter. All right? So, example number 1. If we put 0.5 moles of sodium hydroxide into 2 liters of solution, what is the molarity of the solution? Well, molarity is, be careful, it's a capital M for molarity, not to be confused with like a lowercase m, which would be meters. Okay? 0.50 moles for every 2 liters of solution. Okay? So I'm going to do 0.5 divided by 2. That gets me 0.25. Now, this unit is moles per liter, but you can actually use the capital M for molarity, and we just call it a 0.25 molar solution. All right? Let's look at example 2. It says, what is the molarity if we have 80 grams of NaOH in 1 liter of water? So remember, molarity is moles per liter, and they've given this number to us in grams. So the first thing we're going to do is go from 80 grams of NaOH to moles of NaOH. Okay? Moles always gets a 1. Grams always gets molar mass. So we're going to get the molar mass of sodium, which is 22.990, plus the mass of oxygen, which is 15.999, plus the mass of hydrogen, which is 1.008. That gets us our molar mass at 39.997 grams. So we're going to take 80 divided by our 39.997. That's going to get us 2 moles for every 1 liter. So 2 divided by 1 is 2.0 molar NaOH. Okay. Now this is a little trickier because this time we're not asked for molarity, we're asked for moles. So remember, molarity is equal to moles over liters. So we're going to pick this up and we're going to sort of rearrange it. We're going to move the bottom over here. So we're going to do our molarity times our volume. So moles is going to be equal to our liters times our molarity. Our liters was 0.50. Our molarity was 0.10. And this is in moles per liter. So if you look, we've got liters over liters. So liters is going to cancel out, and that's going to leave us with our answer in moles. So we're going to do 0.5 times 0.1. That gives us 0.05 moles. And this was KOH. So this question is really similar, except for this time they're asking us for grams of KOH, which means we want to start by solving for moles, and then once we have it in moles, we'll go from moles to grams. So we're going to use the same equation that we did up here. Moles is going to be equal to our liters times our molarity. So our liters is 2.75 times our molarity of 0.25 moles per liter. Liters are going to cancel. So 2.75 times 0.25 gives us 0.6875. And that is moles of KOH. So now the last step is to go from moles of KOH to grams of KOH. Moles always gets a 1, grams always gets molar mass. So the molar mass of potassium is 39.098, plus oxygen, which is 15.999, plus the hydrogen, which is 1.008. That gives us a molar mass of 56.105. So we're going to multiply that times our moles, so times that 0.6875. That gets us 38.57. We should really round this to 2 sig figs, so that's going to round to 39 moles of KOH. Okay? So that's how you do molarity. Pretty straightforward.